For generations, one name has echoed through the halls of exploration and adventure, a single word synonymous with the ultimate earthly challenge: Everest. This colossal peak, standing sentinel in the heart of the great Himalayas, has long been crowned the undisputed king of mountains. Its very name conjures images of windswept ridges, treacherous icefalls, and determined climbers clad in brightly colored gear, pushing the limits of human endurance. It represents the highest point on our planet, a place where the air is thin and the world stretches out below in a breathtaking panorama of rock and ice. This reputation is not merely a matter of geography. It is a powerful symbol of aspiration and achievement. The allure of Mount Everest is woven into the very fabric of our collective imagination. We are drawn to its sheer scale, its raw and untamable power. It is the final frontier on Earth, a place that demands respect, courage, and an immense amount of preparation. Stories of the first successful ascent by Sir Edmund Hillary and Tenzing Norgay in 1953 are legendary. Tales of human spirit triumphing over nature's most formidable obstacles. Since then, countless others have followed in their footsteps, each with their own personal reasons for attempting the perilous journey. Everest is more than just a mountain. It is a dream, a goal, a testament to our relentless desire to explore and to conquer. This grand mountain has become a benchmark for greatness. When we speak of a monumental task, we might call it our personal Everest. This linguistic habit shows just how deeply the mountain is embedded in our culture as the ultimate measure of height and difficulty. Its peak, at 8,848.86 meters above sea level, is often referred to as the roof of the world. From this vantage point, climbers can, on a clear day, see the curvature of the Earth itself. The physical presence of Everest is so immense, so overwhelmingly vast, that it seems almost impossible to imagine anything on Earth that could stand taller. And yet, our planet is a place of constant wonder and full of surprising secrets. What if our long-held understanding of the tallest was based on just one way of looking at things? What if the title of the world's greatest mountain depended entirely on where you begin your measurement? The story of mountains is far more complex and fascinating than we might first assume. It invites us to look beyond the obvious, to question our definitions, and to explore the hidden dimensions of our world. A new perspective might just reveal a contender for the crown, a giant that has been hiding in plain sight all along. How do we decide that one mountain is taller than another? The answer seems straightforward. We use a measuring tape, albeit a very sophisticated one. The most common and widely accepted method is to measure a mountain's height, or its altitude, from sea level. Imagine a perfectly calm, global ocean extending across the entire planet. The height of a mountain is simply the distance from the surface of this imaginary ocean to its very highest point, its summit. This is why we always see heights written as meters above sea level. It provides a consistent universal standard that allows us to compare peaks from different continents fairly. This standard method is logical and incredibly useful. It has allowed us to create detailed maps of the world and to understand the topography of our planet with remarkable precision. Using satellites, GPS technology, and advanced surveying techniques, scientists can pinpoint the height of a summit with an accuracy of mere centimeters. It is this very method that confirms Mount Everest as the highest point on Earth's surface above the water. Its peak juts further into the atmosphere than any other land-based point, which is an undeniable and impressive fact. This measurement defines our atlases and shapes our understanding of the world's geography. However, this is not the only way to think about a mountain's stature. Another way to measure a mountain is to consider its total height from its base to its peak. Imagine a mountain standing on a flat plain. Its height would be the distance from the ground at its foot all the way to its summit. This is known as its topographic prominence, or its base to peak height. This measurement tells us how tall the mountain is as a single, complete structure. For many mountains on land, this measurement is very similar to their height above sea level. But what about mountains that do not start on a flat plain? This is where the story gets truly interesting. Some of the largest mountains on our planet do not begin on dry land. Their foundations, their true bases, are located deep beneath the surface of the ocean, hidden from our view. If we were to drain the seas, we would see colossal structures rising from the abyssal plains of the ocean floor. Measuring these mountains from their submerged base to their sunlit peak would reveal their true staggering size. This alternative perspective challenges our conventional definitions and opens the door to discovering a new champion, a mountain whose immense scale has been concealed by the blue waters of the sea. While Everest reigns supreme in the world above the waves, a mighty challenger has been waiting patiently in the deep. This contender is not found in the rugged Himalayas or the soaring Andes, but on a tranquil island in the middle of the vast Pacific Ocean. It is a mountain known as Mauna Kea, located on the Big Island of Hawaii. To the casual observer, Mauna Kea appears as a gentle, sloping giant, its summit often dusted with a surprising layer of snow in a tropical paradise. It rises to a respectable 4,207 meters above sea level, which is less than half the height of Mount Everest. By the standard measurement, it is not even in the running for the world's tallest. However, the story of Mauna Kea's height does not begin at the shoreline. Its true foundation lies far below, on the floor of the Pacific Ocean. The Hawaiian Islands are, in fact, the peaks of enormous volcanoes that have grown from the seabed over millions of years. Mauna Kea is the largest of them all. If we were to measure it from its underwater base to its summit, the numbers would tell a very different story. From its foot on the ocean floor, this colossal volcano rises for approximately 6,000 meters before it even breaks the surface of the water. Its journey does not end there. It continues for another 4,207 meters into the sky. When we add these two parts together, the hidden portion below the sea and the visible portion above it, Mauna Kea's total height is simply astonishing. It measures over 10,210 meters from base to peak. By this measure, it is nearly 1,400 meters taller than Mount Everest. Imagine stacking 1.5 of the world's tallest skyscrapers on top of Everest. That gives you a sense of Mauna Kea's true scale. This dormant volcano is, by this definition, the single tallest mountain structure on our planet. It is a giant of unimaginable proportions, most of which has remained hidden from human eyes for its entire existence. This claim does not seek to diminish the formidable challenge and grandeur of Everest. Instead, it invites us to appreciate the different ways in which nature expresses its power and scale. Mauna Kea's record-breaking height is a geological marvel, a result of volcanic forces working over immense timescales deep within the Earth's mantle. It is a reminder that some of the world's greatest wonders are not always the most obvious ones. The title of tallest mountain suddenly becomes a matter of perspective, a debate between the highest point above the sea and the tallest structure from foot to crown. Mauna Kea is located on the Big Island of Hawaii, the youngest and largest island in the Hawaiian archipelago. Unlike the jagged, sharp-edged peaks of the Himalayas, which were formed by the collision of tectonic plates, Mauna Kea is a shield volcano. This means it was built up, layer by layer, from countless flows of very fluid lava. This process gives it a distinct appearance, a broad, gently sloping mountain that resembles a warrior's shield lying on the ground. Its slopes are so gradual that you can, in fact, drive a car all the way to its summit, a journey that takes you through an astonishing variety of ecosystems. The journey up Mauna Kea is a journey through different worlds. The lower slopes are covered in lush tropical forests, rich with native plants and birds found nowhere else on Earth. As you ascend, the landscape changes dramatically. The vibrant green gives way to a stark alpine desert. Here, the ground is covered in reddish-brown volcanic rock and cinder cones, creating a landscape that feels otherworldly, almost Martian. The air becomes thinner and colder, a sharp contrast to the warm beaches just a few hours' drive away. This dramatic transition underscores the sheer vertical scale of the mountain. At its summit, Mauna Kea offers a spectacle unlike any other. You are standing above the clouds, which often form a thick white blanket below, stretching out to the horizon like a soft, fluffy ocean. The sky above is a brilliant, deep blue because you're above 40% of Earth's atmosphere. This high, dry and stable air makes the summit of Mauna Kea one of the best places on the planet for astronomical observation. It is for this reason that the summit is home to some of the world's most advanced telescopes, powerful eyes that peer deep into the mysteries of the universe, far from the light pollution of cities. The physical geography of Mauna Kea is a story of fire and ice, land and sea. It is a dormant volcano, meaning it has not erupted for over 4,500 years, but scientists believe it could erupt again one day. During the last ice age, a glacier more than 70 meters thick covered its summit, leaving behind polished rocks and unique geological formations. This incredible history, from its fiery birth on the ocean floor to its icy cap and its current status as a window to the cosmos, makes Mauna Kea a truly unique and fascinating geographical feature, a gentle giant with a dramatic past. Comparing the summits of Mount Everest and Mauna Kea is, well, rather like comparing two different planets. The summit of Everest is, honestly, a place of extreme hostility to life. At 8,848.86 meters, it is well into the so-called death zone, an altitude where the oxygen level is so low that, quite simply, the human body cannot survive for long. Temperatures can plummet to minus 60 degrees Celsius, and winds can, at times, scream past at the speed of a hurricane. It is a brutal, unforgiving environment of ice, rock and thin air. Reaching this point, you see, requires months of acclimatization, immense physical strength, technical climbing skills, and frankly, a significant amount of luck. It is a true test of human limits. Now, in stark contrast, the summit of Mauna Kea, at 4,207 meters above sea level, is far more accessible, though it presents its own challenges. While you can, in fact, drive to the top, the rapid change in altitude can cause severe altitude sickness if one is not careful. The air is still very thin, with 40% less oxygen than at sea level. Temperatures regularly drop below freezing, and snow is surprisingly common in the winter months. However, it is not the life-threatening environment of Everest's peak. People can visit for a few hours to watch the sunset and gaze at the stars, a profound experience, but one that does not require the same level of mountaineering expertise. The physical challenge of climbing each mountain is also, well, worlds apart. Ascending Everest is one of the most arduous and dangerous undertakings in the world. Climbers must navigate the treacherous Khumbu icefall, ascend the near-vertical Lhotse face, and brave the final exposed ridge to the summit. The entire expedition is, without exaggeration, a multi-week ordeal. In contrast, the most common way to climb Mauna Kea is via a winding road. For those seeking a physical challenge, there is a hiking trail that covers 10 kilometers with a significant elevation gain. A very difficult day hike, but not a technical mountaineering expedition requiring ropes and ice axes. The view from each summit reflects its unique character. From Everest, one sees a seemingly endless sea of jagged, snow-covered peaks, stretching across Nepal and Tibet, a raw, powerful and intimidating landscape. The world below is one of rock and ice. From Mauna Kea, the view is one of sublime tranquility. Below lies a vast blanket of clouds, and beyond that the deep blue of the Pacific Ocean. At night, the view is not of the Earth, but of the heavens. The Milky Way galaxy stretches across the sky in breathtaking detail. a site that connects visitors not to the Earth below, but to the universe beyond. The science behind measuring these two colossal mountains is as fascinating as the peaks themselves. For Mount Everest, determining its exact height has been a long and challenging scientific quest. Early surveys in the 19th century used trigonometry, measuring angles from distant points on the Indian plains, to calculate the mountain's height. These early efforts were honestly remarkably accurate. Today, scientists use high-precision global positioning system technology. A GPS receiver was placed on the summit during a 2020 expedition, which communicated with satellites to determine its precise position, leading to the current official height of 8,848.86 meters. Measuring Mauna Kea's full height from its base is a different kind of scientific challenge, one that takes place largely underwater. To map the ocean floor, scientists use sonar technology. Ships equipped with multi-beam sonar send pulses of sound down to the seabed. By measuring the time it takes for the sound to travel down and bounce back, they can create a detailed three-dimensional map of the underwater landscape. This technique, known as bathymetry, has revealed the true shape and scale of the massive underwater portion of Mauna Kea, allowing scientists to pinpoint the location of its base and calculate its total rise from the ocean floor. One surprising fact about Mount Everest is that it is still growing. The Indian tectonic plate is continually pushing northwards into the Eurasian plate, forcing the Himalayas to rise. Scientists estimate that Everest is growing taller by about 4 millimeters every year. This means that with each passing generation, the roof of the world gets just a little bit higher. This slow but relentless geological movement is a powerful reminder that our planet is a dynamic and ever-changing system. The mountains we see today are not static monuments. They are active participants in the Earth's long and dramatic story. Mauna Kea also holds a surprising secret related to its weight. This enormous volcano is so massive that its weight has actually pushed down the oceanic crust beneath it. The mountain has sunk several kilometers into the seafloor under its own immense pressure, a process called isostatic depression. This means the total volume of rock that makes up the volcano is even greater than what its current base-to-peak height suggests. It is a mountain so large that it has literally dented the surface of our planet. This incredible fact further solidifies its status as one of the most massive single structures on Earth. So, if Mauna Kea is arguably the tallest mountain on the planet, why do so few people know about it? Why doesn't it hold the same legendary status as Mount Everest? The primary reason lies in our human perspective and the power of definitions. For centuries, our world was defined by what we could see and what we could reach. The highest point on land, the one that reached furthest into the sky from the ground we walk on, was the natural and logical champion. Sea level became the universal starting line because it was a visible and practical standard for a land-dwelling species. The story of Everest is also deeply intertwined with the history of human exploration and nationalism. The race for Everest in the mid-20th century was a grand adventure that captured the world's imagination, full of daring expeditions and heroic figures. It represented a quest to conquer the third pole after the North and South poles had been reached. This history has given Everest a cultural significance that goes far beyond its physical dimensions. It is a symbol of human achievement, celebrated in books, films, and documentaries, cementing its place as the top of the world in the public consciousness. Mauna Kea's story, on the other hand, is more subtle and scientific. Its claim to greatness is hidden beneath the waves, revealed not by brave explorers with ice axes, but by scientists with sonar equipment. The idea of measuring a mountain from its base on the ocean floor is a relatively modern concept, born from our growing ability to explore the deep sea. It lacks the dramatic human-centric narrative of Everest. There is no race to the base of Mauna Kea in the same way. Its discovery as the tallest mountain is a triumph of technology and a shift in perspective, which is intellectually fascinating but perhaps less emotionally gripping for the general public. Furthermore, the experience of Mauna Kea is one of accessibility and tranquility, not of extreme danger and conquest. You can drive to its summit to watch the stars. This accessibility, while wonderful, makes it seem less epic than the perilous journey to the top of Everest. We are often drawn to stories of struggle and survival, and Everest provides that in abundance. Mauna Kea's gentle slopes and serene summit do not fit our classic image of a formidable mountain giant. It remains a hidden champion, its true scale appreciated by geologists and astronomers, but its story largely unknown to the wider world. Beyond its geological significance, Mauna Kea holds a profound cultural and spiritual importance. For native Hawaiians, the mountain is a sacred place, an ancestor, and a physical manifestation of their connection to the divine. Its name, Mauna e Wakea, means the mountain of Wakea, one of the progenitors of the Hawaiian people. The summit region is considered the realm of the gods, a place where the Sky Father, Wakea, meets the Earth Mother, Papa Hanyomoku. To ascend the mountain is to enter a sacred temple, a place of reverence and spiritual power. This deep cultural connection means that the summit is a place for traditional practices, for prayer, and for honoring the ancestors. Ancient stone shrines, or ahu, still dot the landscape, testaments to centuries of worship. Native Hawaiian cultural practitioners continue to visit the summit to perform ceremonies, leave offerings, and maintain their spiritual ties to this sacred peak. This perspective stands in stark contrast to the view of the mountain as simply a site for recreation or science. For Hawaiians, Mauna Kea is not a thing to be conquered, but a revered elder to be respected and cared for. This sacred status has led to complex and often painful conflicts over the use of the mountain. The construction of astronomical observatories on the summit, while scientifically valuable, is seen by many native Hawaiians as a desecration of their most sacred site. It has sparked decades of protests and a powerful movement to protect the mountain from further development. This struggle highlights a fundamental clash of worldviews, one that sees the mountain as a gateway to the cosmos and another that sees it as a sacred connection to the earth and to the divine. In this way, Mauna Kea is much more than a geological giant. It is a cultural heartland. Its story is not just about height and measurement, but about identity, spirituality, and the ongoing conversation about how we should relate to the most special places on our planet. While Everest is a symbol of international adventure and personal achievement, Mauna Kea is a powerful symbol of indigenous identity and the enduring spiritual bond between a people and their land. It teaches us that a mountain's true importance cannot always be measured in meters alone. In the end, what does it mean for a mountain to be the greatest? Does the crown belong to Mount Everest, the highest point above our global sea, the roof of our terrestrial world? Or does it belong to Mauna Kea, the single tallest structure from its hidden base to its starlit peak? The answer, perhaps, is that both are champions in their own right. The debate itself is what is most valuable, as it pushes us to look at our world with fresh eyes and to question the simple labels we so often take for granted. It shows us that there is more than one way to measure greatness. The story of these two mountains celebrates the wonderful surprises that nature still holds. It is a thrilling thought that a giant taller than Everest could be hiding in the familiar landscape of Hawaii, its true scale concealed by the ocean. It reminds us that even in the 21st century, our planet is full of secrets waiting to be uncovered, not just in remote jungles or deep oceans, but also in the re-examination of places we thought we knew. These discoveries fuel our curiosity and inspire us to keep exploring, to keep measuring, and to keep learning about the incredible world we inhabit. Understanding how we measure things like mountains is more than just an academic exercise. It teaches us a valuable lesson about perspective. Our understanding of the world is shaped by the tools we use and the questions we ask. By changing our starting point from sea level to the ocean floor, we reveal a new truth. This applies to so many aspects of life. A problem that seems impossibly large from one angle might become manageable when viewed from a different perspective. Finding new ways to measure and define our world can lead to breakthroughs not just in science, but in our own lives. So, let us celebrate both Everest and Mauna Kea. Let us stand in awe of Everest's formidable peak, a testament to the planet's raw power and the human spirit of adventure. And let us also marvel at Mauna Kea, the gentle giant whose true stature reminds us of the vast hidden wonders of our world and the importance of looking beneath the surface. Each mountain tells a different story, and each contributes to the magnificent and complex picture of our Earth. They teach us that greatness comes in many forms, and the world is always richer and more wonderful than we imagine.